So far we've seen several different types of data: primitive, interval, enumeration, itemization. But all of them have been what's called atomic. In each case, a single data value really consists of just one value. But lots of times we want to represent different kinds of information. Information where two or more values naturally belong together. So for example, we might want to represent the XY position of an object moving on the screen. Or we might want to represent the first and last name of a single person. Or we might want to represent the name, supervisor, and salary of an employee. In all those cases, there's two or more pieces of information that naturally belong together. To do that, we're going to need compound data. And we're going to cover compound data in 3 videos in a now familiar form. In this video, we'll learn a basic mechanism called define struct that allows us to create compound values. In the next video, we'll learn how to update the how to design data recipe for compound data. And in the third video, we'll see that the how to design worlds recipe works pretty much unchanged for compound data, and we'll make our most elaborate world program yet. What we're learning is a new kind of definition called define struct. So here I'm going to define a struct or a structure, and I'm just going to call this one pos as an abbreviation for position. So that's the structure name. And what comes next is something called the field names. And in this particular structure, I'll say that the fields are X and Y. So you can see I'm making a structure that's going to help me represent XY positions. Now when I write that definition, if I run it, I don't get any value back because define struct is a definition just like the defines we've seen so far, function and constant definitions. It doesn't produce a value, it just declares definitions. In this case, it declares 4 definitions. The first one is a thing called a constructor, and it works like this. I can say make pos of 3 and 6. And what that does is it produces a position structure for which the value of the X field is 3 and the value of the Y field is 6. That's an ordinary value, so I can do something like make it be the value of a constant like P1. And if I run that, now P1 is a constant, and if I go down here and I just look at P1, Dr. Rackett's going to show it to me, or I should say the BSL language is going to show it to me in the form of a call to the constructor, make pos 3, 6 in this case. So that lets me put 3 and 6 together into a pos structure. How do I then take them back apart? Well, before I show you that, let me just quickly do another example. And now I'll show you how they come back apart. The way they come back apart is that this define struct also defined 2 selectors. One of the selectors is called pos-x, and if I say pos-x of P1, then, well, I get 3 because P1 is the make pos 3, 6, and so the X field of that is 3. So pos-x of P1 is 3, and unsurprisingly, pos-y of P2 is 8. Okay? So this produces 3, and this produces 8. So make pos is the constructor, pos-x and pos-y are the selectors, and there's one more function that define struct defines for me, a thing called the predicate. It, in this case, is called pos question mark. And if I say pos question mark of P1, I get true. And if I say pos question mark of some value that isn't produced by make pos, like hello, that gives me false. So this is true, and that's false. So just to review quickly, the way to form a define struct is open paren define struct, some name, which is going to be the name of the structure, a parenthesis, and then some number of other names, 1 or more, that's the name of the fields. That definition sets up a constructor, which is always called make dash the structure name. It sets up as many selectors as there are fields, which are always called the structure name dash the field name. and it sets up a predicate, which is always called structure name ? So that's the basic define struct mechanism. In the next video, we're going to look at how to design compound data definitions. In other words, data definitions for compound data. And they're going to use define struct as a supporting mechanism.